Hi guys, so this is the final review video on differentiation under Math SL. The difficulty level of questions in this video is advanced, and I shall attempt the 3 questions on the screen in front of you, and I shall begin with question 1 shortly. So question 1 came in paper 1, May 2015, time zone 2, question 5. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. You might be wondering why I've put this question under the advanced videos. This question in and of itself is not extremely difficult. However, it shall lead to question 2. It serves as an introduction to the next question, which is fairly challenging. So anyway, we are given that f of x equals e to the power of negative 2x. We are required to write down f dash, f double dash, and f triple dash, which is represented by this notation. So this is very straightforward. E to the power of negative 2x becomes negative 2 e to the power of negative 2x. Then I differentiate the blue expression again to get 4e to the power of negative 2x. Then I differentiate a third time to get negative 8e to the power of negative 2x. So in question B, you are required to find an expression of the nth derivative of f of x. So we want the nth derivative, fn. So you just need to find a pattern in the blue, green, and purple expressions right there. So what do we notice about them? And the black expression as well. We notice that all of them have the same exponent, e to the power of negative 2x, e to the power of negative 2x. So this does not change. So obviously my nth derivative shall have e to the power of negative 2x. So what does change? If you analyze each of the derivatives, you shall find that the first derivative had negative 2. The second derivative had negative 2 times negative 2. The third derivative had negative 2 times negative 2 times negative 2. Each time I multiply the answer by negative 2. So this means that the blue expression had negative 2 to the power of 1. The green expression had negative 2 times negative 2, which is negative 2 to the power of 2. So negative 2 to the power of 2 corresponds to f dash, the second derivative. Then negative 2 to the power of 3 corresponds to f triple dash, the third derivative. Hence, negative 2 to the power of n corresponds to the nth derivative. So take a minute to write this down if you will, and make sure you understand the explanation of this question, because it shall help in the following question a lot. So the second question that we shall tackle came in paper 1, November 2016, question 10. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So you are told that f of x equals cosine x, and in A you are required to find the first 4 derivatives of f of x. So if f of x equals cosine x, then f dash equals negative sine x. We differentiate that to get negative cosine x. We differentiate again to get sine x. And finally, we differentiate a fourth time to get cosine x. You will notice that f4, the fourth derivative, is the same as the original function. Hence, f5, the fifth derivative, which is not written here, shall be exactly the same as f dash, the first derivative, which we shall call f1 from now on. So f1 is going to be the same as f5. f2 is going to be the same as f6, and so on and so forth. Next, you are required to find the 19th derivative of f of x. So, since as we mentioned, the first derivative f1 of x is going to be the same as the fifth derivative f5 of x, there is a pattern here. So f1 is the same as f5 equal to f9 equal to f13 equal to f17. We want f19. This is two derivatives away from f17. So this is f17 double dash, the dash of the dash of f17, the derivative of the derivative of f17. This is going to be the same as f1 double dash, so the derivative of the derivative of f1. So I'm going to differentiate f1 twice. This gives me f3. In other words, since f19 is two derivatives away from f17, this is going to be the same as something that is two derivatives away from f1. There is your f1, there is your f3, which is two derivatives away from f1. Hence, f19 is going to be the same as f3, which is sine x. In question B, you are told that g of x equals x to the power of k, where k belongs to z positive, the set of positive integers. You are required in I to find the first three derivatives of g of x. So g of x equals x power k. I'm going to differentiate that. This gives me k x to the power of k minus 1. Next, I'm going to multiply the old power by the constant, and this gives me k times k minus 1, and I'm going to reduce the power by 1. So let's do that one more time. I have k power negative x power k minus 2 here, so I'm just going to multiply the exponent by the constants to get k times k minus 1 times k minus 2, and I'm going to reduce the exponent by 1, getting k minus 3. In double I, I'm required to find p given that the 19th derivative of g of x looks like this. So k factorial over k minus p factorial times x to the power of k minus 19. I need to prove that the 19th derivative of g of x shall look like this. So first, let's find a formula for the 19th derivative of g of x given what we already have. So the first derivative of g of x is k x to the power of k minus 1. So let's first look at what happens to the powers of x as I progress with derivatives. The second derivative has x to the power of k minus 2. The third derivative has x to the power of k minus 3. Hence, the 19th derivative of g of x shall have a power of k minus 19. So this is the first part. As for the second part, we notice that the first derivative had a constant of k. The second derivative had a constant of k times k minus 1. The third derivative had a constant of k times k minus 1 times k minus 2. So the 19th derivative is expected to have a constant of k times k minus 1 times k minus 2 all the way up to k minus 18, because 18 is just 19 minus 1, similar to the fact that here 2 is 3 minus 1 and 1 is 2 minus 1. So I reach up to the derivative minus 1. So the 19th derivative shall reach up to k minus 18. The 24th derivative shall reach up to k minus 23, and so on and so forth. So I've arrived at an expression of the 19th derivative of g of x. I want to compare this expression to the show that expression, which looks like this. K factorial over k minus p factorial times x to the power of k minus 19. This is my right there. I want to show that the expression that I've obtained for the 19th derivative looks like this, and to find p. So let's take a look at how to do that. So the concept of k factorial is to multiply k by k minus 1 by k minus 2. For example, 5 factorial is 5 times 4 times 3 up until you reach 1. 10 factorial would be 10 times 9 times 8 times 7 up until you reach 1. K factorial is k times k minus 1 times k minus 2 and so on and so forth. K minus 1 factorial shall begin at k minus 1 and continue. K minus 2 factorial shall begin at k minus 2, which is this term, and continue with the rest of the terms. K minus 3 factorial shall begin with this term and continue with the rest of the terms. So every time we neglect one of the terms of k factorial. In the first term, k minus 1 factorial, we neglected the k. Then in k minus 2 factorial, we neglected the k minus 1. In k minus 3 factorial, we neglected k minus 2. And so on and so forth. So we keep removing terms as we progress. So if I compare these factorial expressions, I can notice that k factorial is actually just k times k minus 1 factorial. And k factorial is actually k times k minus 1 times k minus 2 factorial, which starts from here and progresses till the end. So what is k factorial in terms of k minus 19 factorial? Notice the pattern. So k factorial is k times k minus 1, or k times k minus 1 times k minus 2 factorial, or k times k minus 1 times k minus 2 times k minus 3 factorial. So if I want to reach up to k minus 19 factorial, I would write k times k minus 1 up to k minus 18. And you will notice that this is the same as the gold expression right there. Hence, if I want to get an expression for this gold expression alone, how can I do that? Simply by dividing k factorial by k minus 19 factorial. This shall give me the red expression right there. So k factorial over k minus 19 factorial shall give me k times k minus 1 times so on and so forth up till k minus 18. Hence, we can replace this expression in the 19th derivative, the gold expression, with k factorial over k minus 19 factorial. Hence, using the show that expression, p shall equal 19. So in CI, you are given k equals 21, h of x equals f19 of x times g19 of x, the 19th derivative of f multiplied by the 19th derivative of g. You are required to find h dash of x. So we have two expressions in x multiplied by each other. So this shall be my u and this shall be my v. But for simplicity, instead of u and v, we'll just call them f19 and g19. So what is h dash? H dash is uv dash plus vu dash. So uv dash is actually f19 times g20, because if v is g19, then v dash is g20. So uv dash becomes f19 g20. vu dash becomes g19 f20. So in order to find h dash of x, I shall evaluate f19 g20 plus f20 g19, which is uv dash plus vu dash. So let's get expressions for the four terms. We said that our u is f19, and we know that f19 is sine x, and we got that in the first part of the question. We know that f20 shall be the derivative of f19, so u dash, which is f20, shall be cosine x. This is my u dash. Next, g19, I have an expression for that from the last part of the question, which is k factorial over k minus 19 factorial multiplied by x to the power of k minus 19, right? So now that I know the value of k, I can substitute that into the expression, and I obtain 21 factorial over 2 factorial times x squared, since k equals 21. So now I have an expression for g19, which is 21 factorial x squared over 2. Of course, 2 and 2 factorial are the same thing, because 2 factorial is 2 times 1. So this is my v. Next, I need to find my v dash. So I differentiate this term. I differentiate g19 in order to obtain g20. So 21 factorial over 2 is a constant. I multiply this constant by the original power, which is 2. So I get 2 times 21 factorial over 2. And I reduce the power by 1, so x squared becomes x. If you simplify this, you cancel the 2's together, and you get 21 factorial x. So in order to write h dash equals uv dash plus vu dash, we said that the u is sine x, there it is. The v dash is g20, which is 21 factorial x, so there it is. And then I'm going to add this to vu dash. So my v is 21 factorial x squared over 2, there it is. And my u dash is f20, which is cosine x, so there it is. In other words, this is f19 g20 plus g19 f20. Finally, I need to show that h dash of pi equals negative 21 factorial over 2 times pi squared. I shall simply plug pi instead of x into the gold equation. So sine pi is 0. So the entire term is 0. This bracket is entirely equal to 0. And I need to evaluate the second bracket. So the second bracket is cosine pi. Cosine pi is negative 1. 21 factorial over 2 remains as it is. And x squared becomes pi squared. Hence my final answer is negative 21 factorial over 2 pi squared. And this concludes what was a challenging question, undoubtedly. I hope you have understood it. I shall begin the third and final question shortly. So the third question came in paper 2, May 2005, question 7, I and double I. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So in I am told that f of x equals 3x squared over 5x minus 1. I want to write down the equation of the vertical asymptote of y equals f of x. Obviously, the vertical asymptote has to do with the values of x that would make this function not work. And since this function is a fraction, I cannot have 0 in the denominator. So the vertical asymptote exists at the value of x that makes this denominator 0. Hence, the vertical asymptote shall exist at x equals 1 over 5, because this makes 5x minus 1 equal to 0. Next, I need to find f dash of x, giving the answer in this form, a squared plus bx over 5x minus 1 all squared. Obviously this is a quotient rule problem because we have a fraction, so u over v, and we apply the quotient rule. So there is my u, there is my v, and my u dash and v dash are their derivatives. So vu dash is 5x minus 1 times 6x minus uv dash, which is 3x squared times 5, over v squared, which is 5x minus 1 all squared. All that remains for me is to simplify the numerator. The denominator already looks like what I want in my final expression. So I just need to expand and simplify the numerator, and I get this blue expression right there. And when I simplify, I get 15x squared minus 6x in the numerator. In double I am given a function g of x defined for negative 3 less than x less than 3. I'm required to analyze the behavior of g dash and g double dash of x. So I'm given some information about the two functions, and I need to justify in A, or just write down the value of x for which g has a maximum. So what is the definition of a maximum point? A maximum point is a turning point, hence g dash must be 0. And a maximum point is a point where the curve is frowning or downwards concave. Hence, a maximum point is a point where g double dash is negative. So I'm looking for a point where g dash is 0 and where g double dash is negative. So g dash is 0 either here or here. So I just need to figure out which of these corresponds to a negative g double dash. So g double dash is negative in this range, negative half to 3. So negative half to 3 is the range that I want, hence I'm going to choose the 1. So when x equals 1, g dash is 0 and g double dash is negative. So this is for question A. The answer to question A is x equals 1. For question B, on which intervals is the value of g decreasing? So the value of g shall decrease when g dash is negative. So where is g dash negative? In these two intervals, negative 3 less than x less than negative 2 and 1 less than x less than 3. So there are my answers to A and B in case you would like to copy down. In question C, I need to write down the value of x for which the graph of g has a point of inflection. So obviously, a point of inflection is where g double dash is 0 and goes from positive to negative or vice versa. So it has to be positive before and negative after and 0 at the point, or negative before, positive after and 0 at the point. Obviously, the only point where g double dash is 0 to begin with is x equals negative half. Hence the answer is x equals negative half. Finally, in D, I need to sketch the graph of g, clearly indicating the position of the maximum point, the minimum point, and the point of inflection. So obviously, I know that I have a maximum point here, a minimum point here, and a point of inflection where x is negative half. So you have a smiling curve followed by a frowning curve, and in the middle there is your point of inflection. This should be simple enough. If this is not enough for you in terms of clarity, you should assess where the slope is negative. So in this region, the function is decreasing. In this region, the function is increasing. In this region, the function is decreasing. In this region, the curve is smiling or concave upwards. In this region, the curve is frowning or concave downwards. And you know where the turning points are, so this should be enough to draw the curve, which shall look like this. So I've located my minimum and my maximum, and I know that there is an inflection point at negative half, and before the inflection the curve is smiling, after the inflection the curve is frowning, or concave up and concave down. So this is how your sketch should look like. Take a minute to write this down if you will. This concludes our video. I hope you have found it useful.